Hi everyone. We are here today at the Fully Connected conference, user conference. This is our first ever user conference for Weights and Biases. We are, as you know, in the session, a panel session on state of MLOps tools. We have a few luminaries with us. We are really honored to have them with us. So we'll start by introducing them. Let's first start with Will Benton from NVIDIA. Will, do you want to take a quick minute to introduce yourself?
Yeah, hi, thanks. I'm Will Benton. I'm a product architect at NVIDIA focusing on data science and practitioner experience. Before joining NVIDIA, I worked in sort of MLOps and tools for MLOps on Kubernetes. And sort of before that, distributed systems and programming language research. So that's where my biases are.
Awesome. Great to have you, Will. Then next, Ben Firshman, founder and CEO of Replicate. Ben, do you want to quickly introduce yourself?
Yeah, sure. I've got a background in starting a few developer tools companies. Most recently, I was head of open source product at Docker, and then taken that experience to Replicate now, where we've got partly we're building an open source tool called Cog, which is a little bit like Docker for machine learning. We've also got Replicate, which is a place to run machine learning models in the cloud.
Awesome. Welcome. And then we have Robert Nishihara from co-founder and CEO of Anyscale. Robert, do you want to introduce yourself?
Hey, I'm Robert. I'm working on building Anyscale, and we're commercializing Ray, which is an open source project aimed at making it easy to build and scale machine learning applications. So, as you probably know, machine learning is incredibly computationally intensive. You need to run it across tons of machines or tons of GPUs, and we are trying to make it easier to program and run and build and scale these kinds of applications.
Awesome. Really great to have all three of you here. And my name is Gourab. I support the customer success organization within Weights and Biases. And my background is in machine learning and data science. And now I have gone to the other side, and cannot call myself technical anymore. But I'm still working with our customers that are deeply interested in everything and all things about ML. So with that, let's jump into this panel. I want to start with a little bit of a lightweight question here. So I have two kids, and every time someone asks me which of them are my favorite, I'm super thrilled, as you would know. But I have some similar questions for you guys, actually. So I will start with Robert. Anyscale and Ray overall is an end-to-end platform, and you have a lot of different tools kind of playing in that platform. Which one in your mind is adopted the most by the users, and which one is lesser known but would be really impactful if was more adopted?
Yeah, that's a great question. And so let me provide a little context here. Ray is like scalable Python, right? Ray lets you scale Python applications across clusters. And then Ray has an ecosystem of, similar to how Python has an ecosystem of libraries, Ray has an ecosystem of scalable libraries on top. And things like training, scaling training, data ingest, preprocessing, serving, inference, and so on. I think the most common, you asked about the most common workloads we see people running and scaling on top of Ray are training workloads, serving workloads like model deployment, and batch processing or batch inference workloads. I think one of the things that is maybe least known about Ray is that we also have the Ray data library, which is not full-blown data processing or imagine like SQL queries or structured data processing or that kind of thing. It's really targeted at the kind of data processing you need to do in order to do machine learning. So imagine ingesting a bunch of data, pre-processing it, feeding it into training, and things like that. And that's actually, we see people, it's less widely adopted than the others, but we see people using Ray data to process petabytes of data every single day and using it at a pretty tremendous scale. So I think, and of course, you can't do machine learning without working with data in some capacity. So we think that's a pretty critical piece of the ecosystem.
Yeah, I'm fascinated to hear that, because for Weights and Biases, we always talk about experiment tracking because ML practitioners are so used to kind of talking about training and model training, all of that. But I think one of the most underrated product feature is artifacts, which is basically kind of like similar idea that how do you actually version models and data sets and all of those things. and it's not as like hot as experiment tracking, but it is one of the most useful and underrated feature, that in my opinion as well. So it's very, very interesting to hear that. I will have a question for Ben for Replicate. I think I know the answer of this because I did see your profile image for Zoom right before this. But given Replicate is kind of powering all these open source foundation models, or getting use out of these open source foundation models, what is your most favorite open source foundation model?
Yeah, well, I mean, the thing that's been this incredible movement for open source vision or open source image generation models has been Stable Diffusion in September, obviously. And I think what's been incredible about Stable Diffusion is it's just created this explosion of forks and tweaks and fine tunes and all this sort of thing that would not be possible otherwise. So I think the thing you were saying with my profile picture is Dream Booth, which is it's not a model, but it's a technique for fine tuning Stable Diffusion. And there's just so much interesting stuff that's been built on top of this ecosystem, just because it's all open source and really easily hackable. People have, like, there's obviously fine tuning where you can fine tune Stable Diffusion on your face and create your face as a sort of labeled objects in these models. Similar thing with styles, but we've also seen people do like really creative stuff, like create animation models, like feeding outputs from the model into the next frame of the other model and creating these really cool animations with Stable Diffusion. Things like creating texture generators with Stable Diffusion. Things like I forgot the name of it now. The model where they took spectrograms, they fine-tuned Stable Diffusion on spectrograms, and then turned Stable Diffusion into an audio model as well. And there's just so much interesting stuff that's being built there. Particularly excited about recently about some of the more advanced ways of fine-tuning Stable Diffusion as well. We recently released LoRa on Replicate, which it's like Dream Booth, but just like an order of magnitude faster. So you can train these models in just sort of 5 minutes, I think it is, and then the weights are only these sort of 10 megabyte files instead of them, almost like a diff instead of the whole 4 gigabyte Stable Diffusion weights. And we're just going to see more and more of these kind of advancements to make it easier to tweak and hack on these things.
Yeah, I think Dream Booth probably should have a tagline: "It makes you look cool." Like, everyone take their profile photos and submit in there and get something. Awesome. That's cool. And Will, I have a question for you for NVIDIA. So of course, NVIDIA is being used across the board across all industry and use cases. So this one is a little bit of a harder one to probably choose from. But I will ask you a little bit differently, that for out of all the use cases that I have seen for NVIDIA GPU and software stack, which is also very, very highly used, what is, in your opinion, one of the most impactful but not that well-known use case? I think we all talk about the gaming use cases a lot. Of course, we talk about now autonomous vehicles and so on a lot. But I'm curious if you have like something that is a little bit of a surprise or not that well known, but is very, very impactful use case of NVIDIA GPU and software stack.
Yeah, that's an awesome question. And a lot of people think about GPUs as, this is something that I need for high performance computing, right? So I'm doing deep learning, or I'm doing conventional machine learning or boosted trees or something at massive, massive scale. I really think the underrated advantage of NVIDIA's accelerated computing stack is at a human scale, right? Like, what crosses my desk? I want to do exploratory data science, and I want to be more productive, right? So if you think about, you have a regular CPU based workstation, and you have, medium sized data set, tens or hundreds of thousands of records of high dimensional data. Keep me honest, folks. This is a medium sized data set, right? This is sort of I mean, we're not talking about like national lab scale, but if you have that unaccelerated workstation, you're using something like PCA, and you're waiting a few seconds to get an answer. If you wanted to use something more sophisticated, like TSNE or UMAP, you're looking at minutes or even the better part of an hour. And if you live within walking distance of a great coffee shop, that probably doesn't sound too bad. But it's time that you're not engaged with your work, right? It's time that you're distracted, even if it's just a couple of minutes. So that's time that you're going to another tab and you're losing your train of thought. So instead of that, though, if you take NVIDIA's Rapids library and an NVIDIA GPU, you could run tsne or UMAP or a range of other sort of useful techniques for conventional data science on a single node, and find that hidden structure in your data at interactive latencies. Maybe we're talking the few seconds that PCA took. Maybe we're talking less than a second, and then you're not getting distracted.
Nice.
And I think this is
Yeah.
key, right? Throughout the history of human computer interaction, we've seen that any improvement to how much you lower latency and waiting for a computer is going to make the human interacting with the computer way more productive. So I think that's an exciting benefit is you can take the data science techniques that you're doing now, you can do smarter things in the same amount of time, or you can do the same things in interactive latency instead of waiting for it.
That's awesome. Yeah. When we were in Data Robot, when I was used to working in Data Robot, we used to call the boring part of the AI. I mean, the ones that no one really, it's not the fancy, like things, but the simple things like improving latency, improving instant interactivity. That's kind of what actually drives the business value a lot. So really resonates. Thank you, all of you. I know that this was sort of a kind of a specific question to you guys, but let's jump into the more meat of this panel. I think what we are trying to talk about here is how do we see the state of the MLOps ecosystem? And I will start with a very foundational question probably in there. I think it's a little bit of a high level and wider question. But when I started listening to different things about MLOps, it's been a few years, and MLOps has changed a lot. The scope has changed. When I think we first heard about MLOps, it was all about production monitoring and some maybe edge models that you need to kind of like monitor in some ways and so on. But I think what it has changed now is to a much wider definition. And what that means also that the marketplace has become incredibly fragmented into what MLOps will cover. So in that world, I'm curious what you guys think about what do you consider to be what are the essential components that make an MLOps pipeline? What does that look like? And how should they interact with each other? Maybe we can start with Robert, given Anyscale is sort of an end-to-end MLOps platform in that world.
Well, the part that Anyscale focuses on is the compute piece, like trying to make it easy to scale and run, whether it's training or serving or inference or, the data ingest, the things like this. So we're not end to end in the sense that, we don't do experiment tracking, of course. We don't do your observability tooling or your feature store or your model registry or there are many components and pieces you need to do machine learning, and we're focused on compute. That said, I think my perspective here is that it's sort of natural to think of some of these tools as being production focused and some as being focused on the interactive development experience, and both are very important. But a lot of what we find exciting here is trying to bring the the development experience, like the interactive development experience for developers, that human scale that Will was talking about, as close as possible to the production experience and the production tool that you're using, so that you can move back and forth between them quickly. Because one challenge a lot of companies face is they develop a model, but then they'll say it takes them 8 weeks or 12 weeks to get that model in production, right? Because it can often be a different software stack, a different set of tools. And then vice versa, something's going to go wrong in production. You're going to need to go back to debugging or developing and iterate on that. And so, if you have separate teams, separate software stacks, that can add a lot of friction. And so, we think about how to make those two experiences as close together as possible, or how to move seamlessly between them. So that's what I would say about that.
Cool. Will, any thoughts?
Yeah, I think, it's hard to say what's essential in MLOps because a lot of the challenges in machine learning systems are just general software or general distributed systems challenges, right? So I mean, like, is Git an MLOps tool? Right? I don't think it is, but I think a lot of people who are doing MLOps are using version control, right? But I think the essential thing here is reproducibility, right? In almost every case where you're using machine learning in the real world, you want to be able to reproduce and go back to what you were doing at some point in the past. And I'd say that the truly essential components really are the things that support reproducibility directly. So, like you were saying, with experiment management, you also need sort of artifact tracking and environment tracking and data versioning in order to sort of tie those experimental results to how you got them, right? And I guess in a lot of ways, this does wind up looking like your sort of conventional enterprise software supply chain or your conventional application development platform. You have version control and dependency management for code, RBAC and data lineage for data, and you have, the metrics for your running services. You have some way to tie it back to how you got there, right? And so I think actually, in a lot of ways, conventional application development platforms are a good starting point for the primitives you need, but they don't really provide the right user experience for most machine learning practitioners who are sort of less comfortable in the world of sort of software development tools.
Makes sense. So, would you guys say that there are like two types of MLOps tools, like a developer MLOps tool and production MLOps tools, or is it more of a like they should be kind of talking to each other and connected experience anyway? And anyone, feel free to add color to that.
Yeah, I think it's important, like Robert was saying, to be able to sort of have some commonality between development and production. It removes an opportunity for practitioners to make a mistake. But to your point, there are different personas and different sort of backgrounds and different skill sets involved in exploratory machine learning and production machine learning, and we need a way to sort of respect that people are coming from different places.
Makes sense. Ben, in your scenario with Replicate or Cogs, what is the user persona you are kind of primarily interacting with, or your product is primarily being used by?
Yeah, totally. So we're a bit weird, I think, where we don't consider ourselves an MLOps tool because we're primarily building for software engineers, like software engineers consuming these models and sort of machine learning researchers who are creating these models. And sort of, I suppose, our world philosophy, which is maybe a bit controversial, is that those two people who are actually either producing these models or consuming these models in their products shouldn't have to worry about any of this tooling underneath. So in some sense, we replicate other consumers of machine MLOps tooling such that we can build this kind of high level platforms so they don't have to worry about it. Exactly how you draw those lines is complicated because there's some stuff where you have to be aware of these things as the user of it. It's exactly what you define MLOps is maybe part of the challenge.
Are you saying that these are two separate groups of people that are the consumers and the producers, and that there's a very natural kind of interface there and sort of division?
That is, I think it's a bit messier than there's not quite a clear distinction, but there certainly should be an API between these people, and I think that's what we're trying to define with Cog. It's like, okay, what is it's a bit like what happened with like the interface between machine learning researchers and software engineers who want to build things out of these machine learning models. Is a bit like the interface between developers and operations people in traditional software, and Docker was intended as this kind of interface point where it's like, okay, developers just put your code inside this box, and then you can tell operations people just run this box, and you don't really have to worry about what's inside. And the trick there is you can't obviously not completely not worry about what's inside, but you define the right interfaces and definitions around this box such that you can use it as a language for communicating. And I think that's some of the intention of what we're doing.
I think that's a nice way to put it. One thing I would, we hear all the time is just people who teams and people doing machine learning they want their teams or their people doing machine learning to be able to focus entirely on the machine learning part of the work, on creating the models, on using the models, building applications with the models, and not on configuring infrastructure and setting up or building or managing infrastructure. So that's, I think, consistent with what you're saying.
Yeah, there was a screenshot being shared on LinkedIn, I think, last week, that someone added a machine learning researcher to the company Kubernetes channel. And this guy is freaking out, like, don't add me to this Kubernetes. My life was so fine before this. Why do I have to go that direction? But totally hear you. Do you think, though, Ben, to your point, like that the software engineers won't need to think about or worry about what's in the box. Is that applicable for any and all use case? Or in other words, is it possible to replicate? Because I heard you use that word carefully in your messaging. Any and all use case as a generalized box or API, or is it more specific to a certain type of use cases where we can do that?
Yeah, good question. I think certainly the models we have on Replicate are relatively straightforward models to that point. I think there are questions about whether some of the more complex types of machine learning can be wrapped up inside a box. Don't know. Don't have a clear sense of that, to be honest. We haven't tried to define those boxes yet.
Yeah, it's still a work in progress. Makes sense. All right. Thanks everyone for your point of view on there. But let's move on to a little bit more spicier question. So of course, your own tool, you're building it for a very specific reason, and kind of you have a mission in your mind. And of course, we are here at Bits and Biases are also building with a mission in mind to help build the best tools for ML practitioners. But outside of these tools that we have, what in your user community that you're seeing as some of the highest adopted, very popular ML frameworks or toolings that you see that are really getting it right? That's why first taking out the biases that we individually have about our tools, but just looking at it holistically as a ML leader in this market. Which ones do you think users should really be knowing about and using and seeing a lot of value out of it? Maybe Will, you can start.
Yeah, and you put me in a tough spot both by saying I can't talk about weights and biases, and by putting me on a panel with people who are behind some other really cool tools. I've been following Ray since it was a research project, and I've been really impressed with Cog when I've seen it, in action. But we're huge fans of weights and biases as well at NVIDIA. But I think we partner with everyone at NVIDIA, and so I think I want to sort of take a different spin on this question and sort of just call out someone who has, I think, done a good job of making sense of a difficult product category and making sense of a difficult use case, and that's Hopsworks. I think Hopsworks is the sort of the feature store. I think they've done a particularly good job of technology transfer. A real challenge I've experienced as someone who's built tools, and I think everyone sort of is familiar with this, probably on the panel, is that it's really easy to be ahead of the curve, and it's really, really easy to be too far ahead of the curve. Like as a tool builder, you sort of anticipate problems your customers don't even imagine yet, right? And I think that feature stores for a long time have been in this category of, well, I understand that some enterprises who are mature at using machine learning are getting a lot of value out of these, but I don't see how they fit into my business yet, right? And I think Hopsworks has sort of done a good job of sort of evangelizing that use case and also saying, well, not only that, but here's why you don't want to try and build your own, which is valuable, I think, to the community at large.
Yeah, I think so. We'll have to look at it. That space, feature store space, is getting a lot of traction in the more recent times. I think Tekton is another one in that same kind of broad area as well. Makes sense. Ben, what's your thought? What's your kind of choice of such tools?
Everyone really loves to hate on Colab, but it's just been like this core of this image generation community that we've seen. Like what's funny is that Replicate and Cog was almost like a reaction to Colab in that, like, oh, these things are so messy, they don't run half the time, they're not reproducible, all this kind of thing. But what's so brilliant about Colab is that you can just play around with it and tinker with it, and one button you can fork it and make something else, and there's always a URL that you can just like copy and share with people. And it's because of that just sort of freeformity that's created this incredible creativity in this ecosystem we've seen in image generation models. It wouldn't have happened without Colab.
Yeah. In our team, there's two groups. Like one is like very Colab pro. I mean, not the product, but they are actually really fan of Colab. And then there is another group that doesn't believe that Colab should be used in production system. It's fun to get them fighting against each other a bit. Robert, what are your thoughts?
Yeah, it's a great question. We're in this position where because Ray focuses on compute for things like training and serving and so on, our users, if you're using Ray, you have to integrate with all of these other tools, right? And so we do prioritize integration with the rest of the ML ecosystem, whether that is tools like weights and biases or beyond. I think I'm a big fan of any tools that really help improve observability and the debugging experience, because I think one of the big challenges with distributed systems is just when something goes wrong, do you know what went wrong, and do you know how to solve it? And that's obviously, it's hard, of course, when you're debugging like a single threaded program, but when you're debugging a distributed application, it just gets so much worse. And when it comes to tools that do model monitoring, I think are in this spirit. There's companies like Arise, which I think do a great job, and others. But really, companies solving this problem of when something goes wrong, do you know immediately just what went wrong and how to solve it?
Yep. Yeah, we do hear that in our user base a lot more than before. I think on the training side, there are some options. On the production side and inference side, I think more and more that observability need and what exactly you want to log and track and how do you act on it is becoming a pretty strong need. So totally hear you on that. Cool. Thanks for handling that spicy question so gracefully, everyone. So with that, let's go in another not that spicy, but still probably an interesting and controversial question for some of our users. Both Anyscale as well as Replicate, you are working with open source community and infrastructure. And Ben, I think you have your cog product that sounds like open source. Anyscale, of course, has the Ray open source for a while. Given you have both enterprise mindset and the open source community and open source product offering, the question I always have for a user, how do they decide whether they keep using an open source product or when do they move to an enterprise version of that product? I think it's probably a very age-old question coming from the Databricks time a long time ago, that when we kind of started this open core movement in many ways. But curious on your thought that, Robert.
Yeah, well, I think there are companies, I would say it comes down to a build versus buy kind of decision. A lot of companies, many companies use Ray successfully on their own, right? But many of these companies also, build tooling around Ray, right? And you can imagine companies like Uber, which run all of their deep learning and classical machine learning on Ray. They have a large machine learning infrastructure team to really to manage that. That's on call and that's building a lot of the additional tooling around it, whether it is observability or job submission or dashboards and collaboration tools and reproducibility and so on, right? So I think for a lot of companies, if they're looking to essentially focus on product development, focus on the actual machine learning model development and things like that, and are not as interested in spending time building and managing the infrastructure for compute if they don't have to. And so that's when we see companies choosing to go with Anyscale or looking to go with the managed services. Basically, can they move faster? And of course, the fact that we created Ray, we're continuing to develop Ray. We can add a lot of value on top of Ray. We can support their teams and sort of de-risk it for them. That's another factor that is important for them.
Ben, what about you?
I don't think you necessarily need to decide anymore. I mean, most infrastructure companies are now built around this concept of open core. And the beauty of open core is it is the best of both worlds. And that as a user of these systems, you're not locked into any particular technology, but it also means that there's commercial backing behind the thing and probably some kind of broader commercial product built around it that is a complete solution rather than the little open source bit in the middle. And it also means that from the company's point of view, it doesn't look on the surface that it's a good thing that anyone can switch away from you really easily, but it puts the incentives in the right place in that we are incentivized to build a great product, because otherwise you can move away. And for example, working at Docker, it worked fantastically because it was all in Docker's incentive for as many people as possible to use Docker containers. Like, if everybody uses Docker containers, then somehow this is going to be good for Docker. That was, so they wanted it to be open source and wanted everyone to be able to use it. That's worked extremely well for Docker.
Yeah, makes sense. What is your perspective, Bill?
Yeah, so I mean, NVIDIA is also engaged in a lot of open source communities. Certainly, the deep learning frameworks, JAX, Spark, and the sort of PyData ecosystem more broadly are all sort of NVIDIA's open source engagements. And I think like to sort of Robert's point, it's really it's not an either or question, right? It's what do I want to support myself versus what do I want someone else to support for me? And I think there's a lot of value in saying, here's a distribution of a project that you want to use. We've tested it. We've certified it with our partners. We will support you if something goes wrong. There's also a lot of value in saying, here's a managed service that's built on some of these open source components, and you're going to pay us to maintain it for you. Right. I think those are both great models. And certainly one thing that's really been attractive to me, I've been working in open source for a long time. One thing that's really attractive to me about it is your customers pay you, like Ben said, because they want to, right? Because you have a great product, not because they have to.
Right. Have to. Yeah. Yeah. Indeed, yeah. And then I think we see weights and biases being used as we have the free personal version. A lot of customers already start using that, trying that experience, feeling really good about it. And when their need changed, usually that's when they make that decision on enterprise. But I do see like there is still that build versus buy that I think, Robert, you were mentioning, that is always kind of playing a role for it. Like, do you want to take that ownership now or later? You want to push it out for a future cost or not is basically what oftentimes kind of dictates. So I'm glad to hear that we are very aligned on that understanding. Thanks everyone for your attention, and thanks for all this really insightful thoughts from all our panelists. And hopefully the users that attended this panel got something great out of it. Please let us know about your feedback, and thanks again for all the panelists. We'll see you in the next session.
Yeah, thank you.
Thank you. Bye-bye.